All right, so we're talking about radians and degree measures today. So these words should be familiar to you. Nothing up here should be new. So we're talking about an angle. What's an angle? The angle, basically, guys, it's when you have two lines that meet at a, what is that called? A vertex, and they're a distance away, right? The angle is we measure, basically, is the distance one line is from the other. However, when we measure angles, um, what are we really thinking about? Like, where do we get angles are created from 0? Like, for instance, this is my x and y axis. So angles are created from here going to the left. Which direction is that, by the way? Which direction? What direction is starting here going this way? Do you know how we call it? So look back there on the top of that wall.
Clockwise.
So clockwise goes which direction, though? Clockwise goes to the right. So angles are measured counterclockwise. They always start from here and go left, okay? So that's counterclockwise. So we have a initial side, which is usually your 0, right? And then the second line is called your terminal side. And then the angle is created, basically, it's telling you how far they are away from each other now, right? Radian is the measure of the central angle that intercepts an arc equal to its length to the radius of the circle. So this is our central angle in radians, okay? So first of all, students are always like, sir, what are radians? Okay, so how do you get radians, all right? Before I tell you that, real quick, let's talk about what we just said. Now we have regular angles. Positive angles are generated by a counterclockwise rotation, which is what we just said. Has to go counterclockwise. Those are positive. So then, therefore, negative angles are generated by which way? A clockwise. Okay? Standard position is every angle that you ever thought of is in standard position. Okay? As long as it starts here on the x-axis and it finishes somewhere else. Okay? Going this direction. That's what we call standard position. And then coterminal angles have the same initial and terminal sides. Okay? They have the same initial and terminal sides. It says angles are labeled with Greek letters, including, does anybody know those Greek letters? See if you're ready for sororities here. What's the last one? No. So this one, the first one is called alpha. Second one is called beta. And the one we use most all the time is actually called theta. Okay? So alpha, beta, and theta. You don't have to. We're going to say it all the time. So when I say theta, guys, it's usually this one right here. And this is actually the one we're going to use most often from here on all the way up through calculus. Okay, so anytime we talk about an angle, we usually call it, or an unknown angle, we usually call it theta. All right? Now, what is a radian? Okay, what is a radian? So, to define a radian, you can use a central angle of a circle whose vertex is at the center of a circle. Okay, so, imagine you have a circle. Okay, the vertex is at the center of the circle. So then what is the distance between the center to the edge of the circle called? From the center to the edge, what is that called? A radius. So a radian, one radian, is imagine if I got this radius and laid it on the outside of my circle. So that's why it's called 1 radian. I have a little animation that I want to show you that kind of explains it a little bit better. All right? So, it really is. Yeah, for me. The internet's not working. Let me stop the video. Okay, so here we go. It's like I told you. Imagine you had a circle, okay, with any radius. okay, with any radius. And I'm just going to call it r. 1 radian, so the measure of this to this, 1 radian is if I were to take this radius, I don't care how big it is or how small it is, and lay it on the outside of my circle. So basically, like this. Take your radius and you wrap it on the outside. So that's going to be 1 radian right there. Okay? Now, something interesting happens. What ends up happening is, as I continue to go about my circle, a unique number pops up. Pi. So it turns out pi radians is exactly, always, no matter how big or small, half a circle. Okay? So pi is actually 180 degrees. Okay? So then tell me, how big do you think a full circle is? Yes, but in radians. 2 pi. You guys ever heard that? So a full circle is actually 2 pi. Okay? A full circle is actually 2 pi. Or basically, it's 6.283. Essentially, guys, you understand where I'm getting why it's called radian, right? Because what am I using? The radius. Regardless of how big or small the circle is, this is always going to be true. Okay? If I take its radius and I start laying it on the outside of the circle, it's always going to take me exactly 6.283 pieces of that radius to go all the way around. Basically 2 times pi. Okay? So, so basically, what I wanted you to get out of that is that what a radian is, how it comes in about, and why do we use it? We use it, guys, because actually it's a lot easier to use than degrees. Okay? When it comes to mathematics. It's weird because most people understand degrees. We all understand if I say 180 degrees or 360 degrees, right? We all understand what that means. But when it comes to calculations, especially in the upper level math stuff, radians are so much easier to deal with. Okay? Now, because of that, we actually have a conversion. Okay? We actually have a conversion to deal with. So, one more time. An arc length is the length of the radius. Okay? So we already said a half a revolution comes out to what in the end? Pi. Okay? So half around a circle is pi. A quarter of a revolution then would be what? Pi over 2, half of pi. Right? Pi divided by 2. And then 1/6 of a revolution would be pi over 3. Okay? So these are very handy in something called a unit circle, which we're going to learn. And actually it's extremely useful in calculus. So we're going to learn it, we're going to build one, and we're actually going to hopefully memorize that bad boy by the end of the year. Okay? So, most important ones are pi is a half revolution, half a circle. Pi over 2 is a quarter of a revolution. Can you guys give me these in degrees? What's half a revolution? 180. What about a fourth? That's 90 degrees. What about a sixth? That's 60 degrees. So this is actually 180 degrees. This is actually 90 degrees. And this is actually 60 degrees. Okay? So now you already know that 180 degrees is pi radians. 90 degrees is pi over 2 radians. And 60 degrees is pi over 3 radians. Okay? But, everybody got that? Okay? But what about everything in between? Okay? What about everything in between? Because obviously I'm missing a bunch of degrees here. Right? I'm missing a bunch of degrees. How many in a full circle, by the way? How many degrees are in a full circle? 360. So I have, 357 other degrees that I got to worry about. So there's actually a formula. Okay? So this is actually what happens. This is called the unit circle. Okay? This is called the unit circle. So this is what it breaks down to. You don't have to copy this. This is going to go online, and we're going to build our own here in a bit. But I was just showing you the breakdown. Okay, so it starts at 0. Then I get to, that's 30 degrees, that's 40 degrees, that's 60 degrees, that's 90 degrees, and then so on and so forth. Okay, and we're going to build these. So it's pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, and then it kind of ends up, and then once I get all the way back around, That's 2 pi, but don't forget it was also where I started, which is 0. So they're actually the same angle. You would not be able to tell the difference between a 0 angle and a full circle. Okay? So, let's talk about converting between degrees and radians. So today's a very simple, easy lesson. It's just converting. It's going from degrees to radians and vice versa from radians to degrees. Okay? So, to go from degrees to radians, all you have to do is multiply degrees by pi over 180. Pi radians over 180. See where it says rad? That just means radians. That's just the unit of measurement. So you don't really have to add the RAD. You just have to understand that your answer is going to be in radians. Okay? Yeah. So any degree you have, to switch it to radians, all you have to do is multiply it by pi over 180. And your answer will be in radians. Bless you. Okay? Your answer will be in radians. So all you have to do is multiply by pi over 180 degrees, and your answer will be in radians. Okay? Now, what if I wanted to go from radians to degrees? Simple. You're just going to multiply by 180 over pi. Okay? It's 180 degrees over pi. And in this case, your answer will be in degrees. Your answer will be in degrees. Excuse me. Two simple formulas, guys. Two simple formulas. All you really need is to know, how do I go from degrees to radians? You're just going to multiply by pi over 180. My answer will be in radians. How do I go from radians to degrees? Multiply by 180 over pi. My answer will be in degrees. All right? Let me show you how easy this is. Okay? So, let's convert from degrees to radians. Let's convert from degrees to radians. Does everybody have a calculator? Good. Okay, so here we go. It's 135 degrees. It's 135 degrees. So what am I going to multiply this by? Pi over 180. Okay? So you're just going to multiply this by pi over 180. Now, guys, does everybody see this as two fractions, right? This is two fractions, because technically this is over what? 1. This is technically over 1. Okay, so by the way, that's 180 degrees. So now, how do you multiply fractions? Straight across. So you really see that this is going to be 135 degrees pi over 180 degrees, correct? Right? Do you guys see that the degrees will cancel? Because there's one on top, one on bottom. So the degrees are gone. Right? And so all I really am asking you to do is reduce. So can I reduce 135 over 180? Now notice, there's a pi there, correct? But in all the angle measurements, isn't there a pi there? Right? Because it's pi over 2, pi over 4, pi over 3, 3 pi over 2. So guess what you're going to do with that pi? Leave it alone. Leave it alone. So really, I'm just asking you, can you reduce 135 over 180? So, you know how to do that in the calculator? You know how to reduce a fraction in the calculator? It's very simple. 135 over 180, math, enter, enter. 135 over 180, math, enter, enter. And what does it give you? 3/4. So then, what's on top? 3. What's on the bottom? But what was there that I didn't touch? So there you go. It's 3 pi over 4 radians. See how easy that is? All we're really doing is just reducing fractions. The pi is going to stay there because in radians, pi is usually in the answer. Right? So 135 degrees is how much? It's 3 pi over 4. Okay? Let's try 540. Let's try 540. First of all, before you do it, notice something about that? That's more than 360, which means it's going to be more than a full circle. How much is full circle in radians? How much is radians? Full circle? 2 pi. So it's so I'm just giving you a heads up. It's going to be more than 2 pi. Okay? So, the way I'm going to do it is the exact same. Basically, I'm just going to multiply this by pi over 180, which of course is going to be 540 pi over 180. And all I'm asking you to do now is reduce what's 540 over 180. Reduce 540 over 180. It just comes out to a whole number, which is what? So 3 what in our case? Is that more than a full circle? Yeah, because a full circle is 2 pi. See how easy this is? Right? Because right now all we're doing is just converting. We're just converting. So the next one's a little bit more interesting. It's negative 270. Now, obviously, what's the difference here? It's negative. What does that mean, though? That's all it means. It's just going clockwise. Okay? It's just going clockwise. Instead of counterclockwise like it should be, it's going clockwise. Got it? So, does that change my conversion? No. It just means my actual answer is going to be what in the end? Negative. So do the same thing. You're going to multiply this by pi over 180. And so you're basically doing negative 270 pi over 180. Negative 3 pi over 4. 2, sorry. Negative 3 pi over 2. And of course, you don't have to always write the radians. This is the first time we're doing it, so you have to understand your answer is in radians. Basically, if I ever see something that's something pi over something, I already know it's in radians. Okay? Any questions? Very simple, right? So, to go from degrees to radians, all I got to do is what? Multiply by... Yes. You're going to multiply by pi over 180, basically reduce. What should you keep in there if you can? The pi. Okay? So, what about going from radians to degrees? So now my answers are already in radians, and I want to go to degrees. I'm going to multiply this time by what? 180 over pi. Basically just the reciprocal. Okay? You guys notice anything that's going to happen? What's going to cancel? The pi. The pi's are going to go away. One's on top, one's on bottom, right? So they're going to go away. Does that make sense now? Because if it was in radians, there would be a pi there. But since there's no pi, it's no longer in radians. So the pi go away. So essentially it's a negative 180 over 2, which is what? Negative 90 degrees. Remember, we're going to degrees. So make sure you put that. If you don't put that, it's very confusing. You have to tell me this is in degrees. Okay? You have to tell me this is in degrees. Okay? So I have, next one is 9 pi over 2. 9 pi over 2. Again, what am I going to do? Multiply it by 180 over pi. What's automatically going to happen? Pi's are going to cancel. So essentially it's 9 times 180, which is, help me out here. 9 times 180 is what? 1620. Divided by 2, which is 810. Oh, you're giving me the final answer. 810 degrees. What do you know about that? What can you... That's actually more than 2 circles. How much is 2 circles? Anybody? 720. So that's, for you basketball / skateboarders out there, you know, when you do 2 revolutions, right? It's a 720. That's what they call it, a 720. They literally mean you spinning around twice. Right? And then, so number C, wow. Letter C, technically it's a math class, so C can be a number, right? For letter C, example C, it just says 2 radians. It just says 2 radians. But I'm not going to change. So I know this is in radians. But so I'm still going to multiply it by what? 180 over pi. The only difference is there's no pi to cancel. So how do you think I'm going to fix that? Because can I leave a pi in there? No. Degrees don't have pi's. So then here's the thing. It's just going to be 2 times 180, which of course is 360, divided by pi. So you can actually give me a number for that. So what is 360 divided by pi? Now notice, guys, I didn't say 3.14. I said pi. Where is your pi button? Second, the caret, right? So I don't want you to use 3.14. I want you to use the pi button. So what do you get? Point what? Always. How many decimal points do we round to in this class? 3 decimal points. Make sure you round correctly. So this is 114.592 degrees. Okay? So when you're going 2 degrees, guys, you never want a pi in your answer. Okay? You never want a pi in your answer. So get rid of it just by simply doing a mathematical representation. We good with that? Very simple. So, one more time. How do you go from degrees to radians? Multiply by pi over 180. How do you go from radians to degrees? That's it, okay? And then it's just a simple math. All right, so let's talk a little bit more about this arc length. Arc length. So, just by looking at the words, guys, what do you think we're talking about here? Where are arcs in circles? On the outside. So we're talking about their kind of the circumference, right? Agreed? Since I'm a big guy, so I always like to equate this to pizza, because when I think of circles, I think of pizza. So if I'm talking about arc length, what am I talking about on the pizza? The crust. So we're trying to figure out how long this crust is. Now here's the thing. Can I just bust out a ruler and measure a crust? Why not? It's curved, right? It's curved. I can't, and rulers are straight. So you cannot give an accurate measurement with a ruler and something that's curved, right? So we actually have a formula for this. To find the arc length, it's the measurement from one point to another on the outer edge of a circle. Outer edge also called what? Circumference. So we're finding this thing here. We're finding how long is this piece of crust on this slice. Okay? We're only talking about a slice of it. Because if I wanted to know how long the whole thing was, that's just circumference. Right? But now I'm just talking about a slice. And how do I determine how big that slice is, though? How do I determine how big my slice is? This is all they're giving me so far. This is just in general. What is this called again? Theta. It's called theta. So remember, theta is the angle. Theta is your interior angle. So that determines how big your slice is. Okay? So right now, theta is, there's no numbers here, but you can give me a generalization. How big do you think this theta is, this slice is? Just give me generalizations. Give me some, less than what for sure? 90. Fantastic. That's what I wanted to hear. So everybody agree it's less than 90? More than, you think so? Think it's more than 45? More than 30 for sure, right? Okay, so good. So I'm glad we're getting those kind of generalizations in there. So theta determines how big my slice is going to be. Because look, think about this. If I make theta smaller, meaning I'm making my slice thinner, what's going to happen to my arc length? It's going to be smaller. But if I make my slice bigger, my theta bigger, what's going to happen to my slice, my arc length? It's also going to get bigger, right? So here we go. You have a simple formula. You have a simple formula. To find out how long your crust is, to find out how long your arc length is, all you have to do is multiply your radius times theta. Your radius times theta. There's only one catch. That theta has to be in radians. Okay? It has to be in radians. So all you have to do is multiply your radius times your angle, theta, but that it has to be in radians. So then obviously, what do you think is going to happen at some point? If I'm telling you it has to be in radians. Good. So obviously, most of the time they'll give me a degree and I'll have to switch it before I can use it. Alright? Alright, so very simple formula. A, arc length, is equal to R times theta. Now, I do kind of want to point something out because I kind of just messed up myself. A in this case stands for what? Arc length. If I had a capital A, that would stand for what? Area. Be very careful. Be very careful. Okay, we are going to talk about area, just not today. All right, so here we go. Here's the situation. It says the circle has a radius of 4 inches. Find the length of the arc intercepted by an angle of 240 degrees. Okay? Find the length of the arc represented by the central angle of 240 degrees. So first of all, let's kind of draw this out. All right, I'll try my best to make sure it's a decent circle. Okay? So there's my circle. What do I know? My radius is 4 inches in this case. Okay? And I know I have a central angle. What does this represent? That represents my theta. Okay, that represents my theta of 240 degrees. So, can y'all just give me a good estimate of where 240 is? Because we know, okay, so this is 0. I know this is what? 90. I know this is what? Do I know this one? 270. Remember, it's 9 times 1, 9 times 2, 9 times 3, 9 times 4. So 90, 180, 270, 360. Agree? So 240 is somewhere where? This way? I mean, I don't have to be perfect, right? So agree this is about 270 degrees. So do you see that this is a nice big slice of pizza for me? Okay? So I want to know how long it is from there to there. Okay? So I have a formula. My formula is A equals R times theta. The only problem is what? I don't technically know theta. Because theta is 240 degrees, but theta has to be in what? It must be in radians. It must be in radians in order for me to use that formula. So we got to do a little bit of side work. So 240 degrees times what? So basically, guys, what's 240 pi over 180? What does that reduce to? 240 pi over 180. 4 over 3? Make sense? Okay. So now, do I have everything I need? Yeah. My arc length then is simply my radius, which is what? 4, times my theta, which is what? Okay? So, I mean, this is simple math. 4 times 4 pi is 16 pi over 3 inches, technically, in this case. Now, if I said, hey, how long is that crust? And I said, oh, 16 pi over 3. How would your reaction be? Like, what are you talking about? Who talks like that? Right? So then, guys, I want an actual measurement. I want something I can quantify. So what do you think I want you to do at this point? Multiply 16 pi by pi and divide it by 3. So now, and again, I am not using 3.14. I'm using my actual pi button. So what is 16 times pi divided by 3? That's it? Just 7.5? 755? And then does it continue? Or does it stop? Did I round is my question? Okay, so if I rounded, my equal sign changes to approximate, right? My equal sign changes to approximate. So it's approximately 16.755 inches. That's more reasonable, right? That's more reasonable to me say, hey, the crust is actually 16.755 inches. That's about 16 3/4. Make sense? Any questions? Very simple. So how do you find arc length? Radius times theta. There's only one stipulation, though. Has to be in radians. So if it's not, turn it into radians first and then use it. If it is, leave it and just use it. Any questions? All right, that was pretty simple, right?